Hey guys, so last time we saw how we can apply z-scores into the real world problems, right? So now let's go and see another way that we can apply the z-score. So just so we're able to find the probability of any event, right? So for example, someone who's taller than 6'3". We can also find the value that's associated with any particular probability. So for example, what is the height that separates the tallest 3% of people, right? So there I give you the probability of this particular event, and then I ask you for the event itself. So I ask you for what's the height that's tied to this probability of 3%, and in particular the tallest 3%. So now with this type of question, you need to understand what side of the normal distribution the question is referring to. And so just like I did last time where I showed you the z first and then I threw in the full normal distribution problem, I'm going to do the same thing here. So I'm going to start off with z and then bring it back to the actual full normal distribution problem. So for example, if I ask you, find the z, and you see that little z0? That's basically find the number that represents a z. So what the probability that z is less than this number, I'm going to say less than or equal to, so the probability that z is less than or equal to this random number that you need to find is 0.10. So from this number and lower has to be 10% of the distribution. Now can that be on the left or the right? That has to be on the left, and the reason for that is because if it was on the right, so for example, here's where it should be, but if it was over here, can this area all the way down be 10%? No, right? That doesn't make sense. So we say that this z is on the left side because it makes way more sense that 10% is from this z-score on the left all the way down. Does that make sense? So that tells you that left or the right side of the tail that you're focusing on. Now the other side, they can ask you, for example, find the z where the probability that z is greater than this particular number is 90%. Now again, if I was on the left side, can I have 90% above me? Yes, I can. If I was on the right side, can I have 90% from here up? No, right? Because that 90% is way too much area. So on the right side, all the way up, that can't be 90%. But maybe if I move it on the left and I go all the way up, that could be my 90%. Does that make sense? So now let's go and do the other side as well. So here we have, right up here, the probability that z is less than this particular number that I'm trying to find is 90%. That makes sense if it's on the right side because we should be able to have 90% right there, right? So then we try on the left side, and this z, we can't have 90% less than that, right? That doesn't make sense. That's too little area. So this one wouldn't work. And if you get really good at this, you don't really have to do this whole left and right thing. You can kind of just figure it out. But just to start off, let's go ahead and say, what if it was on the left? Does that make sense? No. What if it was on the right? Does that make sense? No or yes, whatever the case may be. And so the other way is the probability that z is greater than or equal to this 0.10, right? So if it was on the right side, it makes sense that from here up, that could be 10%, right, or 0.10. What about from there down? From this z all the way down to the end, that's way too much area. That can't be just 10%. It has to be greater than 0.10, right? So again, start off with the left, check with the right, and see which one makes sense out of those two for the probability to be associated with the one on the left or the one on the right. But now, let's go ahead and bring it kind of all back. So another way that they can ask you this is, for example, like I mentioned earlier, what's the height that represents the tallest 3% of people, right? And so this particular situation here where we're on the left side only can be denoted by the bottom, lowest or fastest 10% of any number of observations, right? So the bottom, they're the worst, so they're going to be on the left. The lowest, that's going to be on the left too. And then the fastest refers to the least amount of time. So fastest always sounds like a good thing, not in this situation. Fastest, it could mean good or bad, but at the end of the day, we're still going to be on the left side. Does that make sense? Because again, fastest means the least amount of time. But now let's move on over onto this one. we're always going to be on the right side if they say the top percent, right? Because if the top scores, the top anything, they're always going to be on the right side. And then the highest is the one on the right, and then we also have the slowest. Right, so the slowest 10% means that they're taking the most amount of time to do something, right? So that's how we do it with our Z, and these are some key words that we can use to help us decide again whether it's on the left or the right. And that's a very important concept, because if you get that wrong, you're going to be on the totally opposite side and get the totally opposite answer. So how do we bring it back from Z now back to maybe the observation that's associated with that Z? The way we do this is x equals the Z score, and whatever Z score we get, and that could be positive or negative, right? Because let's go back up here. It's very important for us to decide if we're on the left, it has to be a negative Z score, right? So I'm going to highlight this because actually this is one situation where people always get mixed up, is that they'll put it on the left side, but they'll forget to switch it to negative because our Z table always gives us back a positive number, right? So find Z such that, let's go ahead and do a couple examples. Find Z such that the probability that Z is greater than this random Z is 0.03. Now again, first question, am I on the left or the right? So the probability that it's this Z or greater is 0.03. So let's go ahead and try it on the left. Let's try it on the left and right actually. And then here we have our mean, right? So the probability that Z is greater than this particular Z is 0.03. So what that's saying is that from here all the way up is 0.03. But if we were on the left, that means from here all the way up is 0.03. Which one of those two makes sense? We should be on the right, right? Because the one on the negative, it can't be 0.03. Even at 0 at the mean, from the mean up is already 50%. So if we move even more left than that, we should be greater than 50%, not at 3%. So it can't be this one. So we're definitely in a positive Z. So that's our area is 0.03. But now how do we find this in our table? So the way we do this is that our table works from what area? What area does our table always give us when we looked up a Z? It gave us from 0 to that Z score, right? So what we have to do is whatever area they're giving us, we always have to switch it back in terms of what's the probability from 0 to Z. That's actually not very difficult, because if from Z, that Z all the way up is 0.03, how much is left over? We know that from 0 all the way up is 50%, right? So the probability that Z is between 0 and this particular Z, right? And that's what that's basically saying. It's 0. My Z is in between 0 and this Z that I don't really know yet. That's why you call it Z0 or Z0. Because you don't really know it, but it's just a number. It's not really any variable. So the probability from 0 to Z is basically 0.5 minus 0.03. Does that make sense? Because here's 50% is the whole thing. 0.03 is the chunk on the right. So then from 0 to Z is 0.47. So that's what we get for that. And now what do we do from here? From here we have to go to our table, but we have to look in a particular place in our table. So before we used the outer edges, right? And that's how we found our probabilities. We said, okay, the Z is this. We look it up and we go down to the proper row and then we go across the right column, right? But now we're working our way backwards. And so that's why I call these reverse problems, because you're not going from here is your value, convert it to Z, find a probability. You have a probability now. You're working your way back to a Z, and then you're using the formula to work your way back to an X value. So let's go ahead and find the closest thing we can find to our probability. So our probability was 0.47, right? So let's go ahead and look this up and see what we get. 0.4. So you basically get the closest you can. I've gotten really good at this. It may take some time for you to get a little good at this, and that's fine. But I've just practiced enough with the Z table that I know from the get-go where things are. But let's go ahead and say that I didn't really know, right? So here's 4591, 4599. So we're at 46 now. 4625, 4633. Cool, cool, cool. Keep going. And we're looking for 47, right? crazy. So here are a couple numbers, and 47 somewhere in here, right? Because we have 4693, 4699, 4708. Now my rule of thumb for this is to always pick the number that's closest to the value that we're looking for. And so sometimes it may not be the exact number that we're using. It may be exactly in between those two numbers. But until we get there, let's go ahead and stick to this. So 4699 seems to be the closest to 4700, right? Because 4706 is 6 away. 4693 is 7 away. But 4699, that's just 1.0001 away from our 47. So I'm going to use that and work my way backwards. So instead of kind of pinpointing the probability, we're going from the probability and going backwards to get our z. So the z that corresponds to that then is 1.8, and let's go up, 1.88. You see that? So that 4699, you go across, that's 1.8, 1.88. So let's go back to our problem. So the z then is 1.88. But you always want to ask yourself if it's negative every single time, because people always forget. Once you do all this work, it's like, oh my god, I'm done, thank God. But no, you have to always make sure at the end of the day that is it negative or positive. In this case, we're still good with the positive because we were on the right side, right? Let's go to move on to the next one. So find z such that the probability that z is less than this particular number is 90. So let's go ahead and start off with putting our z's down, right? So we have 0, and let's try a z at the top. And we'll do a z at the bottom end too. So the probability that z is less than. So less than means that I'm going from this z number and down, right? So let's try here. That's 90 versus this is 90. Which one of those makes sense? For the z to be on the right or the left? Makes more sense for it to be on the right, right? Because there can't be 90% on the left side down. That doesn't make sense. That's way too much probability for us to be on the left side, right? Because at 0, we're at 50% from 0 and all the way down, right? So that means as we move further and further right, we get higher and higher probabilities. So it makes sense that we're on the right side, because if we start at 50, it's going to go 50, 60, 70, 80, 90% is below the z value. Cool, cool, cool. So now, they tell us that the probability that it's less than that is 90. But what are we looking for? Our table always works off of, again, from 0 to the particular z-score that we're focusing on. Does that make sense? So for these problems where it's reversed, we're always going to shade from 0 to z. Whether it's on the left or the right, we're always going to look for that because that's what our table works off of. So the probability from 0 to this particular z-score is... So now how do we get that z-score? That probability. If we know that from this z all the way down is 90, right? We also know that from 0 all the way down is 50, right? So whatever's left over, if this whole big chunk is 90, then we have this chunk here is 50. All we have to do is just subtract those two so that we can get the probability in between. So 0.90 minus 0.50 equals 0.40. So now, again, we're going to look up in our table that 0.40, right? So let's go down to our table, 0.40. Find the closest thing to that. So 0.40. So we got 3830, 3869, 39. So we're getting close. 39, 39, 40. So we're somewhere in between here, right? So which one are we going to pick? 40 is... what I mean by 40 is 4000, right? So 40000 is 20 away from this one. 40 is 3 away from this one, 3997, and 40 is 15 away from 4015, right? So which one are we going to pick? 3997. Beast. So again, we go back to the row that corresponds to it is 1.2. And then we go up to the column that corresponds to it. And we still get 8, right? So 1.28. Let's go back up. So our z then is 1.28. Positive or negative? We're still positive because we're on the right side, right? So that's about it for example 2. And let's move on to our last one. If you plan on giving a raise to the top 10% of performers in a manufacturing company, what is the time for production is this cutoff for the raise? So what time of production is going to be this cutoff? Assume that the average time is 6 seconds with a variance of 2.25. So now we're bringing it all back together, right? So we're going to have a mean. So our mean is 6 seconds. That's the average amount of time it takes to produce this particular product. We have a variance of 2.25. So what do we do to this variance in order for us to get standard deviation? Square root, right? So that gives us 1.5. So we have our mean, our standard deviation, and what are we interested in? The top 10% of performers. That sounds like it'd be the top, but with time is always basically something that screws things up. The reason why I say that is because with time, sometimes the best is the least amount of time. Sometimes the best is the most amount of time. So for example, if I was talking about battery life, your top phones would be the ones who have the highest battery life. But for example, if I was talking about products for rotting, right? A product rotting, you want a product to rot in the most amount of time as opposed to the least amount of time because you want it to last on the shelves as long as possible. So again, time is a very particular type of question. So for these, just be very careful when you're talking about top and bottom and things like that. So if we want the top 10% of performers, do we want the people who perform the slowest or the fastest? If we're talking about a manufacturing company, the person who produces the most in the least amount of time is always the one who's the best performer, right? Because you want people to push out products faster and faster. So in this case, we're going to be on the left, right? And so this isn't a situation where they tell you the probability and you have to decide am I on the left or the right. Here the words and the problem itself tells you, are you going to be on the left side or the right side, right? And so we're going to have this z0. We don't really know what it is. And also this x0. That x0 is a number or the value in terms of the time in seconds it takes that's tied to the z-score. But we want the top 10% of performers, so we want everybody down. So this area here then is the top 10% of performers because they're the bottom 10% or the fastest 10% of people, right? But is that the area that we use for our z-table? No, right? So again, we're doing 0 to z. So 0 to z. So what is that area there? If that area, and we don't really have to do the math very much anymore, hopefully at this point we kind of understand this. From 6 all the way down is 50%, right? If 10% is from this x value down, whatever's left over is 40%. Does that make sense? So hopefully that's okay. If not, you can feel free to refer back to this. This problem here kind of helps you figure that out. So we have our 40%. Let's look that up in our table and see what we get. So when we look up 40, we actually get the same thing, right? So we're going to use 1.28. Let's go back up. So our z then is 1.28. Yay. Right? So that means this becomes 1.28. And now how do we work our way backwards to an x value? The way we do that is the formula. X equals z times the standard deviation plus the mean. Right? So our x is 1.28 times the standard deviation of 1.5 plus the mean of 6. Right? And so once we do that math, we should be getting our answer. But this answer is actually above 6. Right? So what we end up getting is, so we get 7.92. Now, is that our answer that we're looking for? It sounds like it, right? We did our math right. We got everything good to go. We're in good shape. However, we didn't quite use the proper z, right? So here we have 7.92, but our z was actually negative. So this becomes negative, right? And so instead of being 7.92, we should be getting 4.08. And that actually makes a lot more sense because 7.92 is above 6, right? And we're actually supposed to be on the left side. Does that make sense? So if you get 7.92, you're above 6, that doesn't really make sense. So you should be on the left side. So you kind of maybe made a mistake on just the sign of the z-score that you're using in your formula. So that's it for applying our z-score in reverse. So let's go ahead and do a couple more practice problems, make sure we get that, and we're done with our normal distribution set.